Hands up who has used graph databases. Oh, that's good. Hands up those who've used Neo4j. It's pretty much the same hands, really. That's good. My name's Stuart Begg. I've been in the industry for a number of years. I know Andrew from many, many years ago, so although I wasn't a developer at that stage, but I've come back into the fold and have been doing development work over the last couple of years. And I've been working with Matt. So, Matt?
Yeah, I'm Matt Byrne. For the video, I'll talk into Stu's left nipple here. I've been working at Sensis for about 5 years now, contracting. And there's a couple of guys here. Matt Drago, put your hand up at the back. He's one of the guys who did a lot of the work and had the idea from a long time ago about graph databases. So he's pretty integral. And Casper, I just want to embarrass him just because he didn't want to be part of this talk. He's a developer with Neo4j as well.
So we're going to start off by talking about the what and the who, but we've already covered some of the who. But we'll talk about who the customer is for this thing. We're going to talk about the why. Why did we go with the graph database? We're going to talk about how, and we're going to do a little bit of hands-on stuff with that. And we're also going to give you some honest feedback on how our experience with the graph database has gone, and just not only the implementation of it, but our interaction with the supplier of the database as well. So let's move on. What do you know about Sensis? Sensis is the actual customer that we did this work for. So Sensis is largely our advertising agency for providing information about businesses, but also residential information. So you may know Sensis from this kind of product, which is looking at mostly residential information, but it also has businesses in there as well. This one's more about business-oriented information. In the heyday, there was advertising that was involving the Grand Prix with Mark Webber there. And you may remember these ads of GO, GGO down the bottom here, and Not Happy Jan, which has sort of become part of the lexicon as well. So they were the glory days back then when books were the king. You may remember that this kind of thing kind of happened with some of the books as well. So books have their uses in certain ways. You can use them to hold windows open. Who hasn't used them as a monitor stand at some stage? And here are a couple of other novel uses for the books as well. Books are great for finding out information, but they do have some limitations. These days, it's all about digital and providing a much better experience. At Sensis has gone through a branding change, so you'll see this logo, which is on the back of these shirts as well, and I'll cover what these shirts are about in a moment. And these are the major brands within the Sensis stable these days. So there's Yellow Pages, White Pages, which you've seen before, True Local, which is a directory company that was purchased by Sensis, and there's also the mapping service, which is Where Is. All of these are online digital services. This is the kind of advertisement that you would see in something like Yellow Pages Online. There's a lot of information on here from not only the name of the company and its logo, but how you contact the organisation, some of the services that they provide. And so you can get a very graphical representation and an up-to-date representation of what the business is about. This is part of the digital phase of the company. The project that we're going to talk about tonight is a thing which is codenamed Marshall within the organisation, and it is about managing this content and pouring this content into products that the advertisers purchase to use with that content. So digital means for us providing a consistent, relevant and timely experience for the end users, which are the people who are actually seeking information about advertisers and individuals. We want to provide a more responsive experience for people. So if you're producing books once a year, you can't really be that responsive to changes that are happening within businesses. We want to reduce the costs for not only Sensis, but also for the advertisers to provide a more cost-effective way of getting their message across. We want flexibility. We want different ways for advertisers to put their message out there, whether it's videos on the site, whether it's brochures, whether it's just descriptions of the way their business works. We want it to be adaptable. So if you're putting a book out once a year, you can't really adapt and change to what's going on in the marketplace. And therefore, we want to increase the speed to market. So come up with new products, come up with new ideas to be able to execute on those really quickly. So some of the challenges that we experienced within the organisation, as we were going through this retooling within the organisation, ideas were evolving quickly, and as part of that, what was happening is we found that our model was evolving quickly. So what we were looking for were tools that could work with that evolving model, that evolving pattern of doing business. One of the problems that we were trying to solve with the legacy system that we were looking to replace is that there was massive data duplication in there, which caused all sorts of problems for the customers that were trying to get their message out there. If we had to change the same piece of information across a multitude of places, then it was error prone and it was difficult and it was time consuming to get that right. There were some issues with performance of the legacy systems of just trying to get things out quickly. The other thing about the legacy systems is that they tended to dictate the process within the organisation. So therefore, if you were trying to be agile and come up with new ways of providing new products and new ideas for your advertisers, it could be difficult if your back-end systems were dictating, this is the way you've got to do it. We can't do that. This is the way that it works. And those systems were very expensive and difficult to change. Inflexibility in the legacy systems. So, we reviewed a number of off-the-shelf tools. So we looked at a number of tools as we were going through, particularly the modelling phase of the project. One of the first ones we looked at was a hierarchical and fairly traditional content management system. One of the things that we found with that approach is that we found that it was too rigid. What we were looking at was organisations of businesses that had branches. Those branches quite often shared phone numbers. And if you're looking at a hierarchy where you have a business that has branches and those branches therefore have phone numbers underneath, if this branch over here has the same phone number, all of a sudden you've got a link leading from this leaf over here to this one. And when you start to look at it, it's starting to look like a graph. So we were thinking, wait a minute, maybe this hierarchy is not quite the right way to do this. And we were also, if we didn't do that, we ended up with data duplication of duplicating that phone number from one place into another place. We were back in the same spot that we were previously. So what about relational? Well, we looked at relational as well, but what we found is that there was a lot of modelling in tables and join tables. And when we had relationships which were fairly lengthy, of one thing was related to another, which was related to another, one of the things that we ran into was very complex relational queries. And we also found that it was quite slow in doing many hops across all of these relationships to understand how any individual piece of information was related to some other piece of information. And it didn't really suit the shape of the model that we were generating at that time. So finally, started looking at graphs. What we found was when you're drawing things on a whiteboard of you saying, oh, I've got this business and it has a phone number, so I'll associate this with this phone number, and I've got this other business over here, oh, it's associated with this phone number as well. What we found is we were drawing boxes that had all sorts of relationships all over the place. And we'll actually go through an example later that shows how you can build up that kind of model and also refactor it with various changes to those relationships as you go. We found that the querying language within the graph system that we chose, which was Neo4j, was very good and very much aligned to the style of diagram that you were drawing. And we also found that it was quite performant. So even with very large graphs, and we do have a very large amount of content within the system, the performance of the system has been really good. This is the team. You'll see some of these people, like Matt in the middle there, here tonight.
When your company gets an enterprise license, you can get some free t-shirts.
Yes. So that's how it works. That's why everybody's got these t-shirts. And they customise them with a bit of information on the back about the project that you're working on. We got 2 lots of t-shirts. So, you know, one for the first half of the week and one for the second half. We were split into 4 teams, and I'll actually show you a diagram of what those teams were about on the next slide. One of those applications that the team was working on is the one that interacts with Neo4j. And Matt and I were working on the... Oh, I lost my picture.
That's a feature.
That's a feature, sorry. Matt and I were working on the Neo4j part. So the structure of the application that we were creating, In the middle, you'll see a thing called the store, and the store is a bunch of business rules that looks after and manages the content that makes up these advertisements that we're placing digitally. Down the bottom, the data is actually stored in Neo4j. Up in the top left-hand corner, we have the user interface, which is an AngularJS application, which is used to interact with the store. Up in the top corner here, we've got a thing called the publisher. Now, the publisher is the piece of the application that understands what the makeup of the products are like. And the publisher is the thing that takes information from the customer management system up the top here and basically pours content from the store into these templates for products, which are then ultimately pushed out here to the web front ends, like Yellow Pages Online or White Pages Online. The fourth part is this bit down the bottom here, which has been quite tricky, which is migrating the legacy data, because we've got a lot of legacy data from largely relational database systems through the store and into Neo4j, into our new model in the back end. You can see on the far left-hand side some of the technologies we used. It's a Java 8 application largely, other than the user interface up the front end there. It's a Spring Boot application. The whole thing's hosted in AWS. We're using AngularJS for the front end, and we use Gradle and Ansible to orchestrate the deployments and build of the system as well. We're also using Groovy for a lot of the testing framework, so that has worked really well for us. Okay, let's see it in action.
All right. So you want to describe the model that we're after?
The model that we've developed here is just a fairly simple model. We're looking at a couple of businesses. So again, this is the kind of thing that you draw up on your whiteboard of a couple of circles here and a couple of things that are joined to each other. So we've got a business called Widgets, and it has a branch called Widgets, and we've got another business over there called, of course, Acme, which has a head office, and it also has a branch in Sydney.
So before I jump straight into it, how many people have used relational databases? Oh, that's good. So I'm trying to make this seem a bit simpler by comparing it a little bit with relational later on. So I'm really glad that happened. So jump straight into it. So this is the Cypher query browser. This is the Cypher browsing console. Your equivalent of like a JDBC SQL client. And so that first one here is, let's have a look at what Cypher would write to create that. So Cypher is the query language of Neo4j, so we haven't said that explicitly. And it's meant to be kind of like ASCII art with a little bit of object notation within it. So you see we're creating a business here, and it's got the brackets around it to look like the circle. It's got a thing called labels, so you can group like nodes. It's not as structured as a table, but kind of when you're mapping from your application code to the database, it's kind of a little bit analogous to that. So we've got a business here that we're creating. We've given it this is just aliasing it, so we can use it later on in the query to Acme. And it's like an object here. So you've got your name, Acme, and then we have an arrow that points right here. That's big enough? Yep. And so this is our relationship.
We lost our connection.
Oh, what can go wrong with live demos, Auto searching.
We're back.
Okay. So we're creating our relationship here between the square brackets. So we don't really need to reference this later, so we don't need an alias. And it's got the same kind of thing as a label. You call it a type when it's on a relationship. So we've got, it's normally a verb, so it has branch. Just to show that you can have properties on relationships as well. Relationships are first-class citizens, according to Neo. Not exactly for tuning, because you can't really index on them, but according to the brochure. You can still, you don't want to put too much business logic into these, business data. So we just say that the branch, the nature of the relationship was created in 1990, and then we go off to the branch. Once again, name Acme head office. So we're going to create another path here. So we're going to reuse that node of Acme, another branch, Acme Sydney, and so on. So we create a widget one. Actually, this widget one here, to show an example. I didn't really need to alias that because I'm not going to use it anywhere else. But anyway, I run that, And now let's query all of our data. So if we have a look at that, here we go. Normally we play around with this while builds are running, it's pretty amusing. So if you have a look here, we've got widgets, has branch to widgets. It's just a small one, so the branch is called the same. Acme with its head office in Melbourne. I think you can see the relationships down here. Suburb Melbourne. And that's basically created. So if we jump back here to the diagram, you can see it's a direct representation of what we drew up. So it's a really powerful thing that you're talking the same language.
So the next part in our model, as we're going along, we decide that we're going to add some phone numbers to this thing. And as you'll see here, what we're saying is that actually our widgets business is a purely online business. It doesn't have a phone. So we haven't put a phone on that one. But you'll see for the Acme company, we've got individual phone numbers for the branches, but we've got a shared support number that is used by both head office and Acme. So this is where the graph's starting to come into its own.
So if we jump into that. So I've got another one, add some phones. So here we're starting to do a bit of querying while we're creating. So the first thing here with Cypher is we're going to try to match something. So we're looking for a node that's got the label branch. We're going to alias it to Melb. And the search criteria is the name has to be Acme head office. So you could split this up and put a match branch where name equals head office as well. This is just a shorthand. So once we've done that, we've another syntax which I didn't really need to use here, but I'm just kind of showing you different language features, is we can use merge. Merge will create a path if that path doesn't exist. And so we're going to add has main contact to a phone and has support contact to another phone. Here we could have called them has contact and put a property of main or support. But if you really are using the relationships and you really do want to query a specific path, it becomes a lot more performant to be able to hit a particular type. So it's just showing you when you start modeling this sort of thing, you've got to think about which way you want to go. And so the support phone number I want to use again, so you use with, which is kind of similar to wrapping statements in with in SQL, and I'll create the other ones there for Sydney. So once again, we execute that. Get some data. Yeah, it never does it the way you want to start with, but that's fine. And so here we have our 3 phone numbers and our widgets, and voila.
So now you would have noticed that we had a suburb on the branches. Now what we've decided is that we're doing a directory here, so it would be nice if we could do some queries based on the actual suburb itself. So what we're going to do is a bit of a refactoring. So our model's evolving, and now we're going to pull the suburb out as an individual node. One of the things that you find with using this kind of graph is when you've got millions of nodes out there, the way that the graph works particularly well is you use a query to find a particular node within the graph, and then you use the relationships to move off that. And there's indexing, which we'll cover a little bit later on how you find that initial node. But the idea is find the node and then use the relationships to find other information that's associated with it. So in this instance, we're saying it's probably easier, rather than to use the index to find all the individual nodes that have a particular property on them, let's find a particular node and find everything that's related to that. So that's the kind of refactoring that we're going to do in this case.
And so in this simple example, for modelling purposes, this is probably over normalisation, as you can do in relational as well. But you might want to put supplementary information on that suburb. So it's just for demonstrative purposes for refactoring. So if we did want to look for all of the Melbourne branches, for example, straight away, we could just match branch equals Melbourne, return them. So it did serve its purpose there, but if we want to move them to separate nodes, then here we can match all of the branches, and I'm going to be removing the suburb off the branch, so this just makes it runnable more than once. So filter only where the suburb still exists, and this is where we really do use the merge, because there's more than one suburb Melbourne, and so what it's going to do here is only create that suburb if it doesn't exist already. So we know there's 2 with Melbourne, so it'll only create 1. And here we'll create the relationship from that branch, call it resides in, to this new suburb, and remove the property of suburb. So if I execute that, that'll show, I've just returned the subgraph or some subset of data that we've created. But once again, just to make sure I'm not lying. it never grows twice. So here we've got Acme, and it looks exactly like that. I won't bore you by getting it exactly right. You can style these, so we've put you can tell it this label, use that colour, so that's the trickery we use to make it look exactly like that. Oh yeah, you'd talk about what we're trying to do.
In working up this example, one of the other things that we did was we implemented in SQL as well, just so that we could feel the pain. What we found is that we ended up with a lot of joining tables between the individual pieces of information that we want, like the branches. You end up with lots of tables in between. So what we've done here is we've just done a comparison between, we're not going to show all of the SQL, we're not going to show all of the Cypher, but we're just going to show a comparison between one of the Cypher queries against the SQL query. And you'll see a couple of similarities between them, but you'll also see some of the differences that go on with them as well.
Yeah, and so it's not, I mean, this example isn't just to slag off SQL, it's been paying my contract rates for a while, so it's really to show you that there are similarities and they do make it a little bit easier to learn. So this is an example where we want to aggregate information for all Melbourne branches. So we want to get a count of all of the Melbourne branches, the minimum number of phone numbers on a Melbourne branch, and the maximum number. So if we go back here, we'll see that one of these branches doesn't have any phone numbers and one of them has 2. So you'd want a count of 2, a minimum of 0, a maximum of 2. Really exciting example. So we're going to match once again a suburb of Melbourne. You can put the relationship arrow pointing back. So we want a branch that comes into it that resides in. And then optional match, it's the equivalent of your outer join. So optionally we want to match a branch that either has a support contact or has a main contact to a phone. And then first of all, we're going to need to aggregate at a branch level. So for each branch, get a count of the number of phones. So that's the width. And then finally, we get a count of all the branches, the minimum number of phones and the maximum number of phones. And just to prove it, no, what have I done? Okay, I won't prove it. But if we did the same thing in SQL, you see you kind of follow the same kind of pattern. So we've got the width, and you've got your select here that's going to aggregate at a branch level. So we're going to look for a name, a count of the phones, and then this is where we have the many-to-many tables, which can become tedious when you haven't had to deal with them. So you've got the branch, a many-many between branch and suburb, and then we're joining that suburb back into the many-to-many, and we've got a left join. So we've got our outer join here to the branch phone because the phone isn't mandatory, where the suburb is Melbourne. And one of the things that's really annoying with SQL in this case is most of the time when you do aggregate functions, you put your select columns here and you put your group by, you add one up there and it says, oh, it's not in the group by. And it's another example of where you're getting penalised for majority of the things you do just because you could probably concatenate some columns here. And so Cypher doesn't have that. if you want to reduce the columns, you can just use another with and just step through and reduce the data set. So it's a nice thing. And then once again, we're selecting from that, we're selecting the count of the branches, the minimum and max. So you see, with Cypher, they've tried to keep a lot of similarities with SQL where they can to make it easier for developers. They've removed stuff where there's benefit, and obviously where they're completely different, they have. But once you get a handle on some of the Cypher basics, it's not a very difficult language to learn.
Some of the things that we did along the way, our graph and our model has a time-based component to it. And the idea there was that we, like we were talking about before, about not ever throwing stuff away, we never throw stuff away out of the content model. And what that means is we timestamp everything that's in the model. And what we do is we expire relationships and we create new relationships. So the relationship has a timestamp on it, and it also has whether it's current or not, which is a little bit redundant, but there were reasons for that. And we create new relationships to the new piece of information. What that allows us to do is that at any time you can go back in history and see what a customer's content looked like at any given time. So it's quite powerful for people wanting to know, how has our information evolved over this time? Or I don't ever remember it looking like that. Why does it look like that now? We can step backwards through time very easily through the user interface and see what the data looked like at any given point in time. And that's been quite powerful within the system. We'll talk a little bit more about that time-based thing a little bit later on when we get to some of the challenges that we met with the tool as well.
And so another thing we did is we put a label on, a base label. So Neo4j supports having more than one label. And so it's a good idea to, even if you're not doing the time-based component, to put a base label on all of your nodes. This allows you to do things like create indexes across everything. So indexes in Neo4j are against a label. So you can index one property at a time on a label. When you're modeling your own database, you need to manage your own IDs. They recommend you don't hook into their internal IDs. So you put a unique constraint on, say, an identifier property, on entity. And the other thing it did is when we did this time-based model, whenever you change a node, the idea is you create a new state node that comes off it. So those weren't really our business nodes, so we wanted to separate them. So we had base nodes with state and base nodes with entity, so that helped us there.
We built our own REST client for this thing, and we also built our own object mapping client. We'll talk a little bit later on about how there are some clients out there now, particularly in the Spring Boot area, or Spring area for object to graph mapping. But at the time, partly because of our time-based modelling, but also because of the immaturity of those tools at the time, it was easier for us to build our own mapping layer. Our mapping layer is based on annotations within our Java code. It's quite flexible and it's also quite performant. But it was a bit of a challenge to get that thing up and running. And in fact, we built one of them, and then between phase 1 and phase 2, we rebuilt it based on the stuff that we'd learnt from the first phase of the project. And it's worked quite well. We'll also talk about some other aspects of the data mapping between the application and the database in a bit more detail.
And another thing, you saw our model evolved even through this example, and all databases evolve over time. And there are examples, so you need database refactoring, and Relational's had this for a while, and they've got hooks into other databases. So you've got Liquidbase and Flyway, they're the two main ones. So there was a guy called Florent who has developed Liquidgraph, and we found that, and it was exciting that we could use something off the shelf. Had some good chats with him. He was a very responsive guy. We found some bugs in it in cluster mode where it wouldn't lock out a node, so you might both be running at the same time. And because of, once again, time constraints, and this guy's doing it in his spare time, we couldn't put all our eggs in that basket. The other thing is it used Liquidbase's XML style of roll forwards. And XML is a dirty word these days, but when you've got a database that isn't so tight in its schema, you find you have some business logic in your app layer, and you need to harness that when you're doing database roll forwards, so when you're changing some logic. So we copied Flyaway, and being the creative bunch with our name, we called it Flygraph. It uses Java roll forwards, so that was a big game for us, and it's all code based. So that works nicely. We would love to open source it. The dev manager at Sensis, Joel Blasey, who's standing over there, they're very willing to collaborate with other people, but it does depend on our own client internally at the moment, and so we don't have time to rip that out and open source it, but happy to discuss ideas.
Some of the challenges that we came across, one of them was the learning curve for AWS setup. In the initial stages, it was new infrastructure within Sensis at the time as well, so there was a lot of learning that was going on there. The other thing is that we're using the enterprise version. One of the things that I didn't mention at the beginning of this is if you go to the Neo4j site, you can download Neo. It's open source, so you can even look at the source code of this thing, and you can run it very easily on your own machine. The thing that the enterprise system provides for you is a way of running clustered nodes. So it provides a much more robust implementation. And the other thing that the clustering allows for is hot backups while the thing's running. So with the non-enterprise version, what you're going to have to do is stop it every so often if you want to back it up. We'll talk a little bit about backups and some of the nice features of the backups a bit later on, but the enterprise version allows you to do all of that stuff while it's still running. Yes, we're back to date time. There is no native date time format in Neo4j. It doesn't have that as one of its base data types. They're talking about it, and it will come eventually, but right now it doesn't have that. So all of our date times are epoch integers within the system, which did cause us a bit of a problem with daylight saving at one stage, but we won't go into that. So that's just one thing that you need to be aware of. You're going to have to do your own date time stuff right now.
Problems because we had a bug. It's not because of...
Yes.
We did unit tests, it's not very well. There's some limitations that when we're developing, there's limitations in the indexes and constraints. So indexes, like I hinted at before, on one single property on a label, so composite indexes aren't there. You can get around it by creating, in your business logic, having an artificial property that concatenates them. We use this artificial property to dedupe, so we concatenate a few fields. We SHA encode it so it doesn't get too long. So you can get around those. And the index, in the version we were using, the indexes did not work with range queries. So if you were checking if a property value is greater than a certain number, it didn't work. But there are improvements. Cypher is a fantastic query language. You've seen it. It looks very nice to use, and it is. But it's younger than SQL, so it was still evolving. Through the life cycle of the project we were on, we saw certain improvements coming along there. Some of the things we thought we could do by querying a finite depth of variable range of relationships didn't perform that well, and there are some improvements in that coming as well. And this was a good challenge. There are new performance tuning challenges. So we're used to tuning things the way we are. You just really have to understand a bit more about what the query is doing. It finds a node first, or it finds nodes in parallel threads, and then it traverses the path. So it was a challenge, and it's something that we just stepped up to and enjoyed. Get to know the profiler, and you don't need to know all the terminology in there, but you can kind of get a feel for it.
Yes, I was saying before about the clustering and backup. We found that we ran into a couple of issues with that. Although one of the things that was quite good with the backup system is that if you do have a problem that's in production, the actual database is stored within the file system, so it's just a directory. So if you want to take the whole of production and drop it onto your local machine, you can just take a copy of that directory, put it onto your machine, point Neo at that and start it up, and you have all of the production data in your environment. So you can check out whatever is causing a problem within the production environment. We had a couple of stability issues between some of the releases. Some things that worked in some releases didn't work in some of the new releases. And we had a number of conversations with Neo4j about that. And I think we improved their testing and they improved our testing because we had to make sure that we had coverage of those things. So I think that was a two-way street for both of us. And what's come out of it though is that the stability of the releases that are coming out of there are much improved now, and we're not seeing the sort of surprises that we occasionally saw. I'm not saying it was major things, but there were just occasionally some things that we relied on which mysteriously stopped working or worked in a slightly different way. And this comes back to Matt's point about Cypher being an evolving language, and so is the development of the tool that is Neo4j is going on all the time. Which is one of the reasons why we chose it, because when we looked at a number of the graph products out there, what we saw is that there was a lot of activity and a lot of interest in Neo4j, whereas some of the others, either there wasn't much interest in them or there wasn't a big community around them, but we saw a lot of activity in this space.
So, but there is help and support. The purpose of us showing you these things, we don't want to give you the glossy brochure, we want to show you what went wrong. I would rather see that if I was going to adopt a new technology. There is lots of help and support. So the Neo4j Slack users group is gold. So jump on there, that's our other one. Michael Hunger, he is always on here, he never sleeps. I asked him for some tips for the presentation just to make sure I wasn't lying. He sent me a couple of slide decks just to check. That's the guy there. As you can see, there's a bunch of channels here. So they've got a bot that will invite you to get around the manual invite mechanism of Slack, but jump on there. They'll generally reply very quickly. The community will get involved as well, and you know there's less of an overlap in the time zone for us. But they're also very active on Stack Overflow. I thought, oh great, I've learned a new technology that not as many people know. I'll get some free points, some easy points, and every time I went to answer something, someone else had, so I gave up.
Probably Michael Hunger.
Yeah, probably Michael Hunger. So it's good for people asking questions. Everyone's fighting over it.
The website has some very good tutorials and samples on there. There's a bunch of video things on there which are quite easy to follow and make sense. They show, one of the tutorials is about the relationships between actors and directors in movies, so it shows a number of interrelationships, like how far you are removed from Kevin Bacon, that kind of thing. The samples are good, and one of the other things that they've just introduced recently is a certification process. So you can go through and do an online exam with them and become a certified Neo4j developer, which Matt has done.
Those who can't do and those who can't, no, the other way around. Those who can't get certified, isn't it?
That's right. There's also a GraphDB Melbourne meetup, at which we've presented some of this information previously. But if you are interested in that, there is support in the community for that.
And so if you're looking for features, the other thing, like Stu mentioned, is it is on GitHub. So you can have a look at the code. I think this is Neo4j here. Jump on, have a look at their commits, their pull requests. We did that when there was a bug preventing us from upgrading, but there were some performance tweaks. So we saw in the code they were putting some better defaults for a property, for example, and we just changed the property value on our side. Or you can check if you really think something's regressed. So it's just Java and Scala at the end of the day. I mean, my Scala's not great, I've only done the course, but you can get a feel for what's going on in there.
And the other thing that you get with your enterprise licenses, of course, you get enterprise level support. So when things are going wrong, there's somebody at the other end of the either internet or telephone. And we have a weekly telephone hookup with the guys from Neo to talk through issues and upcoming changes within the product. So they have been extremely responsive in that way, much better than I've seen from some other vendors. So
here's some things we did that can help. And so if you're coming in, it helps you to troubleshoot, helps you to deal with Neo and these issues that are always hard to reproduce on the other side. So number one was auditing our queries. And because we had our own home-baked kind of REST client, all we did is put an aspect around the part that communicated with Neo, used logback to write into CSV format. CSV is a lot easier just to work through. And so that was performing. We were happy with the small performance overhead we had. But it just meant if we had a problem, even if you're putting the thread ID there, you can just throw the data at them and they can have a look. The queries that are running slow really stand out. And in prod, you can limit it to queries that are only going over a certain time. Having a good load test really helps. We were lucky that just by the design of our application, we had this migration application that was already being written. So one of our colleagues, Tio, in the audience, was helping to do that. So what that basically did is sucked in data from a number of data sources, spawned up a huge number of threads, and just threw it at our app. And so that was gold. Whenever a release came out, we were running that because we were working towards our next migration anyway. And that's where we saw some of these the issues that wouldn't normally come up in their standard tests, and because of our model was a bit unique as well. So that was really good. Tune Neo4j as your database grows. So with databases, things like missing indexes don't really rear their head until you've got data in there. Same thing with graphs. As your path from one node to another, if you're querying a certain path, as that grows, you'll need to keep tuning it. And I'm sure when prog goes down or there's an issue, you're going to have to anyway. But it's good to be aware of it. Whoa, sorry.
Too far.
I think that's yours.
One of the things that we got as an advantage from being in AWS is, as Matt was saying, when we were doing the data load, we were trying to do it as quickly as possible, and so therefore we were running multiple threads of throwing heaps of information at Neo simultaneously as it was running through our business layer. And one of the things that AWS allowed us to do was scale up to a very large instance while we were doing this, so we could run multiple threads while all of this was going on. And then later on, when we got back to normal day-to-day, yeah, we need to publish this now, or we need to update this piece of information, we could scale back down to a much more reasonable sized implementation. So being in AWS really helped us in that way. Before that, it's very easy to do backups and restores. That's just one of the points that we've got here. Very easy to move data between environments, very easy to check out problems that you might have in one environment by just loading it. Even on your laptop, you can download, as long as you've got enough space on your laptop, download very large databases and run them up with fairly good performance.
And one other thing with the AWS scaling is it is vertical state. You can't slice your data natively with Neo and horizontally scale in that sense. So all your data has to be in each node. So that's another reason it's good to be able to scale that up. Cypher tuning tips and using the profiler. It's good to familiarise yourself with the profiler. Read a little bit about Cypher tuning, and you'll learn along the way. On that note, we did write an article on this. So Stu and I, with a bunch of our colleagues, co-authored this article, and it was when Neo4j 2.2 was out, and it gives a bunch of performance tips and pointers to other articles. But what it's about is from our beginning, how we built our model, how we tuned, some of these quirks about it, and so it's aiming to help people who are getting in there to familiarise themselves with the tuner and giving them the tools to do it themselves. I've written a comment at the bottom to reference stuff in 2.2 that has been improved in 2.3. So just Google Neo4j real world performance if you want to have a look at that. And so some notable new features since we've been involved with this is there's an official Docker image now. So that may well really help your deployments and simplify things. That wasn't there when we started, so we haven't been using that. If not for that, even for your dev environment, spinning up a Docker instance might be much simpler. Improved indexing, you can do rage scan queries now, so if you're checking greater than, less than, starts with, ends with, and they're improving that even further into 3.0 with more options. Spring Data Neo4j 4. So this Spring Data Neo4j, when we started, only supported Neo4j in the embedded mode, which was basically very early versions of Neo4j. That's why it's got the stupid name, because it was a library, and they can't kick it at the moment, the 4J part. Bolt, it's an always-on connection with binary communication, so it's much more efficient, much less latency. The new 4.1 version of Neo4j with Spring Data Neo4j will support that. Stored procedures, I mean, we try to avoid them in SQL, but they are handy, so they're coming through again. Uniform language drivers, so the Neo4j team have taken in a lot of the language drivers and developed them, maintained them themselves, and tried to keep the experience, the types, the basic operations quite similar, so you can switch between them. These are all things we haven't been able to benefit from. 3.0 isn't out yet. It's still in milestone, I think 5 at the moment. So keep an eye out. Michael couldn't, I tried to get a date out of him, he wouldn't give me one. Open Cypher. So this is fantastic for Neo and for graph development in general. So SQL, relational databases, when they started, all had their own query languages, and when they got together and came up with SQL, that's when it really took off. So Cypher is a great query language. They're trying to open that up. Spark's on board, Oracle are on board, and so a number of vendors. So they're taking this quite seriously. They're trying to give back. They're embracing the competition, but also, you know, for selfish reasons, they want the one that they've invested money in to take off as well. So the purpose of this talk was to try to get people beyond the spikes. A few people have had a go at this. We wanted to really show that Sensis took this, and this is the heart and soul of the content in the company. So they really took a gamble, and this is working at something central to a business. So you don't need to worry about if it's going to be good enough for something so core. So have a go, get into graphs, more collaboration for us. We're contractors. We won't be with Sensis forever. I'm going to Sydney, so Joel Blazy's the dev manager. Sensis are willing to collaborate more, so hopefully you can get into it.
That's it, really. I hope you have questions. I hope you've learnt something, and I hope you'll try it out. It's a lot of fun just to download it. You can the tutorials that I was talking about before are actually interactive, so you can play with a lot of this stuff online without actually downloading anything. But it is quite fun to have it on your own machine and play with it locally. And I think that you'll find it quite refreshing, particularly coming from, as almost every hand went up, from a SQL background. There's just a lot of fun to be had with playing with it, and even if it's just dragging things around the screen, that can be a lot of fun as well. So, any questions? Yes?
What sort of problems is this geared toward to solve? What sort of domains is this applicable?
There's been a lot of work done in fraud detection, so looking at relationships between various entities. There's also been a lot of work done by other organisations in content management. There's a very good content management system out there called Structure, which is based on this, and it's all about interrelationships between the various pieces of content within that system. But anything that has a lot of relationships where you may have a number of hops across that relationship, which is the kind of thing that we've got in the data that we've got in our directory. The Cypher language provides you with a very simple way of defining that and then querying it in a very efficient way. So anything that has, that kind of networked layout. And the interesting thing that we found is that as we were drawing more and more of our model, we were finding more and more of the things that we would have traditionally thought about as tables with join tables between them. When we collapsed them into the actual images that we were seeing on the board, we were thinking, wait a minute, that actually looks like a graph, those things. So any time that you see something that has a number of relationships that are sort of coming back together and maybe folding back on themselves, although ours is a directed graph so that it only ever goes in one direction, that's a good candidate for this kind of technology.
Yeah, and Jim Webber, one of the main brains in Neo, will say that you can represent anything as a graph. I mean, if you've got something with a finite set depth of relationship, like a financial system or something you want to query at that kind of row level, then you're probably all right where you are. But, depends. I mean, it's ironic that relational databases are probably the more relationships is where this one's strengthened. So two ends of modelling or analysing and trying to find patterns.
Off the back end of that, part of Marshall, which is the system that I was showing before, there is some Postgres in there as well, which is just looking after largely tabular-based information or statistical information or, yes, stuff that looks like a table, put it in a table. I mean, that's the best place for it. And I'm not saying use graphs everywhere. There are very, very strong use cases for relational style data in various places, like Matt's saying. So horses for courses. There was another question here. Yes?
You mentioned earlier that you built your own REST client and object mapper, and
Yep.
you said you were going to come back and talk about object mappers that are maybe now available.
Yes.
But I don't think you did.
Yeah,
we did.
That's the Spring Data Neo4j 4. So I don't know if you've been involved, if you've used Spring Data before. It's a nice abstraction even on top of JPA, and it's so it's just it's using the same kind of things that JPA does with the annotation.
And they've also done some other language bindings for languages other than Java as well. So not necessarily a out-of-the-box mapper, but certainly a native interface for those languages for connecting. So not just a Java-based language.
Yeah, so the time-based model we did does have overhead, so if you don't need it, it's going to make things easier for you. And if we weren't using it and we were starting again, we'd definitely have a lot of Spring Data
Now, yeah.
I'm just wondering if you had done any comparisons to things like Titan and Tinkerbell.
We did do some work, particularly with OrientDB in the early stages, and looked at the Tinkerpop stuff. We didn't do a lot with it, mostly because we found that the Neo4j community was bigger and more active. And given that we were betting the business on it, we wanted to find a company that was going to be around for a while and provide the level of support that's appropriate for an enterprise-style application. Having said that, though, and having talked to the Neo guys, it's a very tight community, the graph community, and there's a lot that everybody knows everybody in there. So there's a lot of communication and conversation between the various people within this sphere. So there's a lot of sharing of information, and I think that the open Cypher thing will open some of this up and some more communication within that area. So yes, we did look at it. We did do a bit of benchmarking with them, and we found that the performance of Neo was more than satisfactory for our needs. So yes,
And
good question.
Titan's another one that gets brought up. So Titan's going to sit in front of something else. So it's never going to be as powerful or perform as well as Neo. So it might sit in front of Cassandra, which has eventual consistency problems, or it's just another layer where something can go wrong. So we wanted a native graph database. I say graph, he says graph.
Let's call the whole thing off. Anybody else?
Can you talk about atomicity and just having that data, same queries, accessing the same bit of data and trying to write to it?
Yeah, so
That's a good question.
Once again, it does support opening and closing transactions. So it's very similar to relational database in that aspect. I don't think there's anything unique about it there. So I think it's pretty seamless. The same concepts.
It's important though that as your question is a great question, because it shows that they're serious about their data management here, in that they are supporting that kind of ACID implementation. Because when TO's migration data is really thumping this thing, that's when having good transaction isolation within the application really saves you. And the performance was quite good. We did push it pretty hard, but being able to rely on that kind of facility within the infrastructure of the database itself without having to do it yourself really helped us out.
When you're on AWS, just another thing is you want something with good amounts of memory and I/O. So CPU, it wasn't hitting so hard, so that's just another tip. And when you're looking at your instance types, you can swap between them pretty easily anyway.
Yeah.
We tried to have instances that were kind of large enough to hold all of the data in memory. So that really helped, particularly with the migration part of it. Because as Matt was saying before, one of the things, and as I said at the beginning of this thing, one of the ideas that we were trying to get away from is the amount of data duplication that was coming out of the legacy system. So what we're doing is deduping the data as it comes in. So if we've got multiple threads that are throwing the same kind of information in there simultaneously, we want something that's going to be really performant to do that kind of deduplication as we go. So being able to scale an AWS or your environment in such a way that you can do that efficiently is really good.
At peak loads, you don't need it all the time.
Yes.
So just on that, do you find that the data, once you moved your data into a GraphDB, you got rid of the redundancy? Does that mean that compared to a relational database, you guys saved disk, so to speak? Did you take more? Is there more overhead in the GraphDB?
I don't know, because we've got this, we never delete anything, and we're doing this time-based graph. I don't know about the storage. It's probably about 100 gigs so far. So I don't know what that would be in relational.
No, but it's pretty big. It's pretty sizable bunch of data in there, as you could imagine for a directory of that size.
TAR's down, obviously. gzip's down a lot.
Yeah. Morgan? Yes?
Yeah, just because it's a GraphDB, how do you prevent your queries from being sort of creatively large and sort of spanning the graph? Is it, I think you mentioned time restrictions, but is it also like restricting how long a query goes for?
Oh, Neo can do that. When I was talking about restricting time, that was more for auditing your logging. So I said you could only that's an option to audit over. Neo does have a slow query log, but it's very sequential, and if you're looking at that en masse, it's a bit more difficult. That's why the CSV or some kind of request response time per line was helpful for us. When they do get large, it's just a matter of going through that tuning exercise, getting familiar with the profile and have a look. And what it...
While you're finding that, one of the things that you find is that if you can pinpoint the start or the starting node or group of nodes and then fan out from there, but not too far, then that's a good thing. If it's running over lots of... Yeah, this is the sort of thing that you get.
This was a monster query, but don't let that scare you. But it gives you a nice graphical representation of what your plan looks like, and we probably don't understand a lot of it too. But there are numbers, and so you're going to have a number of dB hits down a certain path. So most of them will look probably something like that, and something stands out when it's got a large number. So you put an index on to try to reduce where it's starting, or you move your matches and wheres, and there's a bunch of tricks there. And then when you hit a roadblock, you jump on Slack and ask Michael for help.
Yeah. So as you might imagine, with all of those balls bouncing all over the place before, they have a very graphical way of showing how the query is being processed. So you can see very fat lines very quickly in that thing, and you can think, oh right, it's pulling a lot of nodes at this point here. Maybe there's some way of avoiding hitting that many times on the database. Anybody else? Yes?
I was just wondering, how well does it scale? Say, for instance, I got a database with a billion rows or records.
Yep.
And how well would it behave with 100 million?
Pretty well.
Pretty well.
Yeah.
A billion.
I don't know about a billion, but we've got a lot of nodes in there. Matt, any guess at how many nodes we've got in that thing at the moment?
For what basis data, we're looking at the order of 1 million nodes just at the start point. So then under each of those start points, you're looking at 3 nodes per advert at a minimum, if not up to about 5. So you'd be looking at about 5 million to 10 million nodes just for the base data. Then once you add the richness of the content and all that sort of stuff, then it starts to blow out. Plus then when you factor into it all the history and the timekeeping that we keep in the state stuff that we keep, it starts to grow rather rapidly.
Yeah, it's pretty. And I think that the mass of it isn't the problem. It's just how much you're returning at once. So if you've got an index that can short circuit a lot of that, we haven't really seen issues as it grows in that sense.
So is it more about keeping your database in memory then?
Keeping your database in memory.
Yeah.
Not necessarily. It's more about trying to to be able to find a short circuit path. So being able to start at something that's got a smaller number of nodes underneath it, so indexing and hitting that, and then starting to traverse down. If you have to traverse a lot of stuff in memory, then that's where it gets slow. And so when you're comparing, if you've just got a table with millions of rows, you're better off sticking to relational. But when you're comparing rows and everything, you've got to remember there's a lot of redundant information in the relational of the many-to-many and the foreign keys and all that. So that's kind of shown in a relationship count, which might also contribute back into that. So, yeah.
We'll leave the questions there. So just thank these guys for talking.